Okay. Just making sure things aren't going to go wonky on me. In case anybody shows up. Okay, dokie. All right, let me take attendance. Okay, so I have Isaiah, I have Abby, I have Stephanie, Connor still. Julian, Brian, Chancellor, Gabby, Connor, Abby, Casey. Whew, I got a full size. Okie dokie. All right. So if you watched the video from yesterday, this is the same warm-up. But I can see who did and who didn't. So how do you, is it Akemi? Huh? Akemi. Akemi. Okay, Akemi. Okay. Well, welcome. Thought you were gone.
I know, I came back.
Oh, yeah. You didn't even miss one of us being in here. It's like Friday we were in here and Wednesday we're back.
Yeah.
All right. Now, I am going to ask you to do the assignments from
Okay.
Monday and Tuesday. That way you're not behind.
Okay.
And you didn't do the assignment from Friday because you figured you were.
Yeah.
Right. Okay.
Well, what was one for Friday?
It was the worksheet
Oh, okay.
with the C. And the worksheet from yesterday was more practice on that same thing,
Okay.
which is basically what this is. So your ESA, guys, is next week. I like Stephanie's like, whoa, big fear in the eyes. Yes, your ESA is next Friday. Oh, look at, listen to the murmuring. Oh my God. All right, here's the thing. So let me just double check to make sure this is recording. Is it recording? I can't tell right now. Yes, it is. All right. Here's what you have to be able to do for your ESA. You have to be able to recognize what kind of sequence it is. That's this, right? You have to be able to write the explicit formula. That's this. It's up here. It's the worksheet from yesterday and the worksheet from Friday. So it's more practice with those. You have to be able to find a certain term in a sequence. That was on the worksheet. And that'll be all from both Friday of last week and from yesterday. And one of the other things that you have to be able to do is talk about multipliers, and that's today, all right? So today is technically the last day of the unit, which means Thursday and Friday and Monday. We're going to have like 4 days of review, okay? So practice, we're going to have 4 days of practice. Sound good? Take a little bit of that anxiety off of you. All right, here's the other thing. To kind of help me with planning these reviews, on Friday in here, I'm going to have a quiz, but it's not like a regular quiz. It's going to go only in like a classwork assignment type of thing, so it's not going to hurt you like a test would if you do badly, but it's going to kind of give me an idea of what you guys need to practice. Does that make sense? Because why would I want to practice something that you guys all know how to do, or a good portion of you guys know how to do? I would rather spend more time reviewing on the things that you need more practice for. All right? Okay, so Monday's assignment was out of the book, and the whole thing was recorded. Granted, we didn't have any internet here till later in the afternoon, so it didn't get uploaded till the next morning. But it was available yesterday morning at 7:30. So the assignment for Monday, all you have to do is watch the video and just write down what I write down and then submit it. Just like today, we're going to do the entire classwork assignment and with including your homework today with me. So you can submit it all as soon as we're done. Okie dokie?
That's the sequence practice.
Huh?
That's the sequence practice one?
No, that was yesterday. Yeah, there was a sequence practice worksheet on Friday, and then yesterday was more sequence practice. So there might be, I might throw another just a couple of days of just doing sequence practice, because that's a lot of what your ESA is going to be about. Okie dokie? All right, so let's review. So determine whether each of the following sequences are arithmetic, geometric, or neither. So we're not going to tell you on your ESA which one is which. You have to determine what kind of sequence you have, and then be able to write the equation for that sequence. So let's just kind of remember how to do it. So if I'm talking about an arithmetic sequence, what does arithmetic mean is happening? Everett?
The same numbers being added to each term.
Same values being added every single time. The equation for the explicit formula, which is the equation, is a sub 1 equals, or excuse me, a sub n equals a sub 1 plus d times n minus 1. All right. Then the other type of sequence we've been looking at is a geometric. What's a geometric sequence at Addison, right?
It's being multiplied by the same number
And it's being multiplied, and we call that the common ratio. Difference is where addition. So it's the common ratio. And that formula is a sub n equals a sub 1 times r to the n minus 1. Okay. So just to let you know, on Schoology, this notebook is already, there's a link to it. And as I'm writing it, it's putting it in Schoology. So right away. So like some students pull up their Chromebooks and just watch me write from there. Okay. Questions so far? Are you awake, Ryan? Are you sure? I don't think Julian's awake. Yeah. Is there more than one Julian in here? All right, so let's look at the first one. It starts at -5 and then goes to 1 and then 7. So first of all, checking for addition is a lot of times the easiest to begin with. So what plus -5 would give me 1. If you're not sure right away, subtract them. Remember, we talked about taking the one that's after and subtracting it. So if I take 1 minus -5, I get 6. Would you agree with that? Now, if I take the next one, if I take 7 minus 1, do I get 6 as well? Yes. Here's the thing, guys. If I give you 4 or 5 numbers in the sequence, you need to make sure that all of them are doing the same thing. If one of them doesn't, then it's not that sequence, okay? So this is easy. There's 3 numbers, makes it easy. But if I'd gone out a few more, and in one of them, I was checking to see if you were paying attention, and I changed one, and so maybe it wasn't 6, it was a difference of, but it was 5, and then I kept going with 6. I'd expect you to be checking to catch that it wouldn't be an arithmetic sequence. So please pay attention. Make sure whatever's happening has to be repeated all the way through the sequence. Okay? Questions? All right, so it is arithmetic. So this one is an arithmetic. And you write the equation, a sub n equals the first number in my sequence, which is -5, plus my d, which is that 6 right there, times n minus 1. Questions? Okie dokies, artichokes? All right, let's check the next one. Well, would I add to 1 to get to 4? 3. If I add 3 to 4, do I get 9? It's not arithmetic. Let's check multiplication. What times 1 gives me 4? 4. Okay. So if I want to look for my ratio, that'd be 4 over 1, remember? Is that also equal to 9 over 4? Are those equal? All right. So I'm making people jump in the back of the room. Then it's not geometric. So if it's not arithmetic and it's not geometric, it means it is a neither. Neither.
You just want us to say neither on like the test?
What, Julian?
Would you just want us to say neither, or would you like want us to say like something else?
No, neither. That's it. Boom. But do you know what happens? Students then try to write an equation for it. I don't ask you to do that, do I? I just say, it's only if they're arithmetic or geometric, then you write the formula. So if it's a neither, you stop. You're done. All right? Don't do more than what you need to do. You're done. And you go to the next one. Well, what would I have to add? I would have to add 10 to 5 to get to 15. But 10 plus 15 doesn't give me 45. No. What would I have to take times? So if I tried my R, is 15 divided by 5 going to be the same as 45 divided by 15? Which is? So if it's the same, then it's a geometric. So therefore, my formula is a sub n equals my first number, a sub 1, which is 5, times my multiplier, which is 3, to the n minus 1 power. And guys, that was that whole worksheet for yesterday. Those of you who did it, that's pretty much what it was, right? Now, what if I asked you to find the 10th term in that sequence? Who remembers? I know you did. Anna? Put 10 in for n. So if I want the 10th term, that means n is equal to 10. And just like our function notation, we're going to put 10 in there. So a sub 10 would equal 5 times 3 to the 10 minus 1. All right. Okay, just give me a second. I have a student. All right. Questions? So if you have to still do the worksheet from last Friday or the one from yesterday, that's what this was. We are not going to, as teachers, we're not going to say, okay, here's all the arithmetic sequences. Here's all the geometric sequences. No, no, no. We're going to just give you sequences and you got to figure out which one is which. All right. You've got to use your deductive reasoning to determine which one is which and then write the equations for those. Understand? Does everybody understand? Thumbs up? Got it? Okay. All right. So today we are working out of the book. And just like for Monday, we will finish pretty much the entire assignment in class. So everybody should be able to turn in their assignment before you leave today. Okay? Then you don't have enough homework. We actually have finished it up like 25 minutes early. And they worked on, those of them who had worksheets and stuff worked on the worksheets to finish up. All right? So I'm going to give you a minute or two to get out a book or get your ebook out. So Akimi, you probably need you need a code for, do you have a device? Okay, why don't you come on over here, let me get you into the ebook. Do I have a pencil? Didn't I already give you a pencil once before?
Yeah, like last class. No, that, she said I could sharpen my phone.
Uh-huh. Is there any other classes you have to use a pencil, or is it just mine? So let's do this.
I lost all my, I wasn't making.
Okay, listen. I'm gonna let you have this one, but you put it back in my, just put it back in my desk, and that way it's always in here. Okay? Okay, good. Okay, so you need to get an ebook. Okay, so go to ebooks.cpm.org. Yeah. Because I'm sure you didn't use it over at RBC, right? Okay, I have to log in and then I give you a PIN number. So log in with Google. Where was your middle school at? Okay, so you use the ebooks at Springview? Okay. And then it's going to ask for a PIN. Oh, hold on. Scroll down. Scroll out. Yeah, a new enrollment PIN. All right. Give me a second. You guys are almost done with me. You know that, right? You only have me for 8 more weeks and you move on to 4 new classes. Huh? Something, huh? Okay. So your PIN is R7L4D. All right, give it. Go to my books up here. Scroll down. You see it right here, integrated one. I should take you right to the. There you go. Huh? We're in chapter 5. And it's going to, so if you just hover, it'll tell you which problems it is. So that's 41. So just scroll down, just go down a little bit more. We're doing 92. So find where you get 92. There you go. There we go. Okie dokies, artichokes. Sonokama. I was trying to sing a song and somebody went, oh. I was yawning. Are you, I bore you that much? Yes? Somebody said yes. I bore you?
Very excited.
I never said anything.
Julian, are you going to follow that chair? Are you sure? If you think I bore you, you should see some of the other math teachers here. Spanish is boring?
Math just bores me.
Well,
Not you.
so Who has, okay, so have any of you got, in Spanish, got Mr. Furtado?
Oh, I want to, wait, I think I have the next one.
Huh? You have his dad? Oh, Miss Gack. Okay. I was like, how do you, you'll find out Mr. Furtado likes Sasquatch. Sasquatch, Bigfoot. Whereas I am a Doctor Who fan, but you can't, you won't be able to get, oh, what is, Sasquatch.
That's a big animal.
I try to laugh in here a little bit. Okay. And you know what? Here's the funny thing. This is kind of interesting for today because it's talking about Pi phones. Because the new iPhone was just announced. The iPhone 12 was announced today. And they're going to shrink it back down. All right. So teenagers and Hollywood celebrities are expected to flock to the exclusive shop in Beverly Hills, California today, clamoring to pick up the new Pi phone. Pi phone. Yeah, this is a Pi. That's a Pi. Yeah, that's a. The Pi phone release began last week when the store pre-sold 100 phones. The store expects to sell on average 15% more this week and each week thereafter. I plan to stand in line all night, said Nellie Hillman. As soon as I own one, I'll be cooler than everyone else. So thanks to the millions of teens around the world seeking to be just like their favorite math teachers, industry analysts predict that the sale of the new Pi phone will skyrocket. The article provides a situation for the number of Pi phones the store expects to sell. They start by pre-selling 100 Pi phones. Predict the number sold during the 4 weeks. Now, here's what I'm going to do, guys. When I do problems out of the book has a way it wants to do them, and then I have a way. I think my way is more logical. So they want you to find the fourth one and the 10th one. So let's just start by finding the first couple. And that's going to help us with the rest of it. All right. So this is 92. So I'm going to make a table where this is the week. And this is the number of Pi phones. Okay, so they're starting off before pre-selling. Right now, it's just pre-selling. Before they have officially come on sale, how much have they sold? 100. How much is it increasing each week? 15%. So that means it's got to go up, right? 15%. What? Okay, I'm going to take this out of my ears. I can hear. Say it again. So here's the thing. How would I find what 15% more of this number is? Everett? Okay, so if I take 15, so everybody knows where you got the 0.15, right? 15% change to a decimal. So if I take 100 times 0.15, you're going to need a calculator. So you have your calculators out. What, Casey? What's 100? Or was it Casey or was it? Oh, I thought somebody said something. What's 100 times 15.15? It's 15. So they're selling 15 more. So how many will they have sold in week 1? 115. Because it's the 100 they started with plus the 15. So if I were to write that out, it's 100 plus 100 times 0.15. Does everyone agree with that? I should see people looking and writing. All right. Now let's go to the next week. So it's 15% more than the week before. So it's going to be 115 plus So that 115 times 0.15. What do we get? 130? 115 plus 115 times, hold on, times 0.15. So at the end of the second week, it's $132, 132.25. Now, I'm not too worried about the decimals right now because you can't have a portion of a phone. Actually, some of you probably do because you've lost most of your screen when you dropped it. Right? Yeah. Okay. As long as it still works, right? That's the only thing that matters. I might not be able to look at my screen very well, but it works. Okay. Would I still do the same thing to do the next part? To find the next week? Am I doing a pattern? I am. Is it very much similar to like a geometric sequence? Would you agree with that? Because we are multiplying and then combining it onto it. So if I want the next one, it'd be 132.25 plus 132.25 times, oh, thank you. Really? I'll just do this. This plus and I get this. So what we're talking about today is called a multiplier. We're going to calculate multipliers. A multiplier these are, since they're not adding the same amount, they're increasing by 15%. A percent is a value that you would use for multiplication. This is like a geometric sequence. So I need to find the R value for the geometric sequence. How do I find an R value? Remember, how do you find the R value for a geometric sequence? Isaiah, you got a question, or you're just stretching? Just stretching? How do you find the R value, guys? We did it in the warm-up. Anna? Division of what? Right. Pick one of the terms and then divide it by the one above it. So two of them that are side by side. And which two would you like to use, Anna? These two? So 152.0875 divided by 132.25. Now, before you do it on your calculator, let's talk about this. Do you think, well, you're like, well, it's just increasing by 15%, so it's going to be 0.15. Would you agree with that? Okay, we'll do it and see what you get. Did you get 0.15? Didn't get 0.15, you got 1.15, right? Hold on. So here's the thing. You see the 15% there, right? 15% of this matches up to the 15% we add here. Where does the 1 come from now? Austin? Not sure? It's not like I'm going to shoot you or hit you or anything if you give me the wrong answer. I like wrong answers because, you know, here's the thing, guys. When you get answers wrong, you know what happens? Thinking and learning. All right. So don't be afraid to give me a wrong answer, because also that also helps me to know how what you're thinking, and maybe I need to redirect it. So are you going to answer now? It's that first value, right? Could I put, let me do this. I'm going to go down here. Could I have rewritten this 115 times 1 plus 115 times 0.15? Could I put the 1 there?
Yeah.
Okay. Well, this 15 here represents 15%. What percent does a 1 represent? 100%. So it's taking the complete value that you're starting with, the 100% of what you're starting with, and adding 15% onto that 100%. And the reason it's adding it is because it's increasing. So our multiplier is going to be 100% plus the new percentage. Okay, or you could use 1 plus the new percentage. Does that make sense? That's the multiplier. So with this, because do you really want to multiply out this table to 10? No. But since we know it's similar to a geometric sequence, could I write an equation for it? Yeah. So what would be my equation? So hold on, I'm going to go around the room. Austin, you've answered. So we did geometric equations and the explicit formulas. It starts off with the first term, right? Abby, what was my first value? 100. Times, what's my multiplier? Let's go to Stephanie. What's my R value? 1.15. To the n minus 1. There's my equation. So now if you come over here, we're going to kind of fill this in. Could I find the 4th and 10th weeks now? All right, so let's do that. So put 4 in for n. Use your calculator. So 4 minus 1. And I want you to put that in there and tell me if you get the next number after 3. You got 152, didn't you? So think here's why. We kind of have to tweak our formula just a tad. When we did all of our sequence notations, we started with term 1, right? Right, we started with term 1 is the first one. What does this start with?
0.
It starts with 0. So that we have to take off that minus 1. Stephanie, all you'll be asked to do on the test, sweetie, is be able to find the multiplier, okay? This stuff that we're doing here, we'll do again back in chapter 8, writing the equations for exponentials, which is what these are. Oh, I'm looking at eyes and I can see like, oh, this is like over my head. Don't panic. Don't panic. Trust me, all right? All right, let me tilt this down. There we go. So with that, now if I put that in, if I take off that minus 1 and I put the 4 there, 100 parentheses 1.15 to the 4th power. And you get 174.9. All right. So and then do it for the 10th. Part B says, would your sequence be arithmetic, geometric, or something else? What would it be? We just said geometric, right? Why? Why is it geometric? Julia, what makes it geometric?
Um,
It's multiplying, yeah. So here's the thing, guys, with the fact that there's only what, 2, 4, 6, 8, 10, 12, 14, 15 of you. I normally have a class of 36 to 40, but so the likelihood, that's how many is normally in the classroom, is 36 to 40. Think about that. 2.5 times what you guys are in here, in the room. So with that, I usually get around to half of them asking questions, you know, but with so few of you, everybody's going to be able to answer questions. Okie dokies, right? Are you listening to me? Yeah. Isaiah? Yeah? Hmm. All right. Part C, the store needs to know how many phones to order in for the last week of the year. If you knew the number of iPhones sold on week 51, how could you find the sales for week 52? We're not doing recursive formulas this year, so we're not going to write it. Just explain to me, if I knew how much was for 51, how could I, at the 51 week, how could I find for the 52nd week? Connor?
multiply 51st week by 1.15.
Yeah, multiply by 1.15. That's it. Multiply by that. This is called the multiplier, guys. It's the because you're multiplying it. Get it? The multiplier, because that's what you're multiplying by. What, Anna? Yeah, they use it as a ratio because it's you were comparing the things. The multiplier is generally going to be when you have percentages. All right. Hey, guess what? We're not done with 92 yet. There's still more parts. But they go. The rest of this goes by faster. Write an explicit formula that starts. We already wrote an explicit, didn't we? Hey, we already did that part. All right, so that means A sub n equals 100 times 1.15 to the nth power. How many, predict how many they will sell in the 52nd week. How do I do the 52nd week, Gabrielle? Sub in for n. There's only a few of you left that I haven't asked a question of. So be paying attention. All right. Calculate that number out. So it's like 100, parentheses, 1.15, 52. 143,313 and about 70. So these are, some of you might be thinking, well, wait a sec, you can have 0.7 of a phone. This is an equation to model. So in modeling, you can have that. If we were actually calculating it, if we were finding the actual values and making a table, we would not get the decimals, but we're using an equation to help us model to make predictions. All right. Well, you know, here's the next thing. The new iTalk, a rival to the PiPhone, is about to be introduced. It is cheaper than the PiPhone, so more are expected to sell. The manufacturer plans to make and then sell 10,000 pre-orders and expects sales to increase by 7% each week. Write an explicit, we're not doing the recursive, equation for the number of iTalks sold during the nth week. So we need to write our equation. So what's our equation? It has our starting value. What's our starting value, Chancellor? 10,000. supposed to be following along also in the book, so it might be a little easier to read. All right, 10,000. Now I need my multiplier. So remember our multiplier is, as we talked about it, it's 100% plus our other, whatever the percent increase is. So remember the multiplier. In this case, because it's increasing, it's 1 plus our percentage. So it's 1 plus, our percent is 7%. So it's 1 plus 0.07. I'm writing it out in separate things. An eyelash in my eye, give me a second. So that you can see where I get it. Okay? Questions on how I got that multiplier? Give me a second. So now I want you to rewrite it for part B. They're not going to increase by 7%. It's going to be 17%. So rewrite the new equation, but this time instead of 7%, you put 17%. What's it going to change to? Stephanie? 1.17, absolutely, yeah. So this 1.07 changes to 1.17. So far, so good? Oh no! Thanks to the lower price, 10,000 iTalks were made and sold initially, but after that, weekly sales actually decreased by 3%. So again, let's start with the equation. So we have our starting value of 10,000, right? How do I find the multiplier this time? Hold on, Austin?
You would, subtract 100% to the, 0.06.
Yeah, we're going to subtract this time. So because it's decreasing, we subtract our percent. So it's a multiplier for when it's increased, you're going to add. When it's a decrease, you subtract. So 1 minus 3%. So that's 1 minus 0.03 or 0.97 to the nth power. Yes, I took 1 minus 0.03. Okay. So then find the 4th week and the 10th week. So put in 4 and put in, and confirm that the numbers went down. And then I want to talk for a second because then we're on 90. We only have 95 and then 102. So we're almost done with the classwork. I want to talk about the different types of multipliers. So you're going to do 10,000 times 0.97 to the 4th power. And then you'll do 10,000 again times 0.97 to the 10th power. So let's just talk about multipliers in general right now. And let you guys get caught up. I still see people writing, so I want to give them a chance to get caught up. Okay, so let's talk about multipliers. So let's just talk in general. I'm going to start with the number 4. And there's 2 patterns with multipliers. When the number is greater than 1, when the number is less than 1, and 1, if it's just multiplying by 1, it's not changing, right? If you're multiplying by 1. So let's look at numbers when the multiplier is greater than 1. So I'm starting with 4. What's 4 times 2? 8 times 2. 16 times 2. What is happening to my result? It's getting bigger, right? So I'm starting here, and it gets bigger when my multiplier is larger than 1. Let's look at it when it's less than 1. So I'm going to start with 4 again, times 1/2. I'm picking easy numbers to work with. What's 1/2 of 4? 2. Half of 2? 1. Half of 1? 1/2. So with this one, when your multiplier is less than 1, your numbers are going to shrink. Okay? So when your multiplier is greater than 1, your numbers grow. When it's less than 1, they shrink. Okay? So just a little bit, so a little bit about multipliers. When your R is greater than 1, it's increasing. When R is less than 1, it is decreasing. Okay? So if you want a percent, if you need to have a certain percent increase, then your multiplier needs to be bigger than 1 by that percent. Okay? Questions? And this is what I just did, right, Everett? No. No, not for this, no. No. So the secret is the number, so looking back at problems, what is the multiplier for each one? We had a multiplier of 1.07. What was another multiplier we had? 1.17. What was another one? 0.97. What was another one? 1.15. Okay. What's the multiplier for this one? 8, 8, 8, 8. What's the multiplier? 1, because it doesn't change. Explain what happens to the terms of a sequence when the multiplier is less than 1, but greater, so less than 1, greater than 0. What happens when the multiplier is greater than 1? So I want you to write in your own words what that means. When the multiplier is greater than 1, what's going to happen? When the multiplier is less than 1, what's going to happen? Okay? And then we're to the last question in your, which is closer to what you're going to have to do for your, yeah, there it is. I just want to make sure it's there. Which is what you're going to have to do for your ESA. For your ESA, I'm going to give you something that says, find the multiple or match the multiplier for each percentage. And it's going to be very similar to the next problem that we're doing, which is 102. Okay, are we ready? Or do we need a minute? I'm looking for pencils in the air, people writing. Okay, let's go on. Last question. This is what you'll have to do on your ESA. Convert each percent increase or decrease into a multiplier. What you'll have to be doing is they're going to give you a percent increase or decrease, and they're going to have a list of multipliers. You have to match them. So like for part A, increase means you're going to add. So that's going to be 1 plus 0.03. So the multiplier is 1.03. Okay. You need to be able to remember how to change a decimal or a percent to a decimal. To moving 2 places to the left or dividing by 100. Decrease means I'm going to subtract. So it's going to be 1 minus 25% as a decimal. You're going to move the decimal 2 places. Make it 0.25. So your multiplier is 0.75. Questions on that? 13% decrease. Again, it's a decrease. You're going to subtract. So it's 1 minus 13% as a decimal is 0.13. And that's 0.87. 2.08%. This one students mess up on. Because they're like, well, it's already got a decimal there, and they mistakenly will leave the decimal there. You still move it 2 places. Empty space, you put a 0. And this is an increase, so you're going to add. So it's 1 plus 0.0208. And that gives me a multiplier of 1.0208. Any questions? But this is mainly thing what you're going to be doing on your ESA. Okay. All right. That's it. That's the entire assignment. I would suggest you right now take a picture of it and submit it, or you will forget.